In this video, we will learn about the measurement of time and simple pendulum. For measuring time intervals, we can use any process which repeats itself again and again after a definite interval of time. In earlier days, time was measured using sundials, water clocks, or by counting pulses rate or heartbeats, etc. The discovery of pendulum principle by Galileo led to the development of pendulum clocks. Mechanical watches make use of the oscillations of a balance wheel. Modern clocks and watches are based on the oscillation produced in a quartz clock. For extremely precise measurement of time, scientists make use of electrical and electronic oscillations and atomic clocks. Here we are discussing in brief the principle of a simple pendulum for measuring time. Now, simple pendulum. An ideal simple pendulum is an infinite point mass suspended by a massless and inextensible string from a rigid support and is capable of oscillation about its mean, that is equilibrium position. Practically, a simple pendulum consists of a small sized heavy metallic bob suspended by a thin but strong cotton string from a rigid support. This is the rigid support, this is the thread, and this is the metal bob. Now, as you can see in this particular figure, this is a simple pendulum. Now, in equilibrium position, the metal bob lies at the position A, which is vertically below the point of suspension O in the rigid support. When the bob is once displaced from its equilibrium position A on one side and then released, the pendulum is set in to and fro motion like this on the either side of its mean position, that is A, with a definite time period under the action of gravity. There are some terms related to a simple pendulum. First is oscillation. So the to and fro motion of a pendulum from its mean position A to the extreme position B, then to the other mean position C, and then finally back to A is called oscillation. Length of a pendulum. So the distance of the center of gravity, that is the center point of the bob, from the point of suspension is called the length L of the pendulum. Amplitude. The maximum distance through which a pendulum bob moves on the either side from its mean position is called the amplitude. In the figure, A to B, that is AB, and A to C, that is AC, are the amplitude of oscillation. Fourth is the time period. So the time taken by a pendulum to complete one oscillation to and fro about a mean position is called the oscillation period or the time period of a pendulum. It is denoted by symbol capital T, and the SI unit here would be seconds. Fifth is the frequency. So the number of oscillations completed by the pendulum per unit time is called its frequency or oscillation frequency, usually denoted by the symbol nu and is pronounced as nu. So the SI unit here would be per second or second inverse or hertz. From the definitions of time period and frequency, it is self-evident that oscillation frequency would be equal to 1 upon time period. That is, frequency is equals to 1 upon time period. Or I can say time period would be equal to 1 upon frequency. I hope this topic is clear to you. Thank you.